So let's go. You know this? We're solving exponential equations with logs, right? And then so you notice each of these are written in terms of an exponential equation. We're just going to go ahead and log using the base of um, the side which has the variables. In this case, we're going to go ahead and do a log base 3 on both sides. Okay, so log base 3 of 3 to the b power equals log base 3 of 17. Okay, remember the purpose of doing this is that this exponential base 3 is gonna offset or cancel this log base 3, and all you're gonna be left is with b equals, and now you gotta figure out what log base 3 of 17 is. I mean, this is actually the best answer, but we want to know about how much, and the direction does say round your answer to the nearest 10,000. Okay, 10,000 is a decimal. So first place is the tens, second place is the hundreds, third place is the thousands, and the fourth decimal place is the 10,000s. So we will need to round each of these answers to the 10,000th decimal place, or the fourth decimal place. Okay. My calculator, and most likely yours, does not have a log base 3. So we're going to have to use the change of base rule for this, which is actually going to be log base 10 or base e of the argument 17 over log base 10 or base e, but you got to use the same base of 3, which is the previous base. Okay, so I'm going to go ahead and type it in log 17, close that parentheses, divided by log 3. Check close parentheses, and you get approximately 2.5789, and that's what we're going to use. Okay, so this is approximately 2.578. That's it. That's B. Alright, so moving on. Solving for this second equation right here. Notice that we have base 12 and base 13, but the r, the variable r, is part of the base 12, so we're going to go ahead and log base 12 both sides. So we're going to go ahead and do log base 12 both sides. So we're going to do log base 12 of 12 to the r power equals log base 12 of 13. Okay. And what really happens, some of you guys may have never heard me say this class, but what really happens is when we do this, we can actually use one of the properties and bring the r, the power properties for logarithmic functions, or logarithmics, and bring the r to the front. So we will have r in the front, and then a log of base 12 of 12 is actually 1. So we end up with r times 1. Okay, or in this case, we can just say these just cancels out, and we end up with r equals, and log base 12 of 13 is really log 13 over log 12. Okay, both base 10. So both of these are base 10. You can use base e if you like, because that's all my calculator has. But I'm using both base 10 for both of these. Okay, but if it's base 10, you don't have to write down 10. So it's just log 13 divided by log 12. You get 1.0322, and that's all we're going to write. So this is approximately 1.0322, because that is 4 decimal places. Okay. Number 3, same scenario. We have a log both sides, and then guess which base we're going to use. Is it base 9 or base 49? That's right. If you said base 9, you are absolutely correct. Log base 9 of 9 to the nth power equals log base 9 of 49. Okay. We're going to end up with n on this side, and on this side, log base 9 of 49. Don't have that in my calculator over here, so we're going to go ahead and use the change of base, which is log 49 over log 9. And what is that going to equate to? Well, going to figure it out. Okay, so log 49 divided by log 9. That comes out to be 1.712. Sorry, 1.7712. Okay, next one. We've got log both sides. And if you either do base 16 or base 67, we're going to go and do base 16 because we need to get rid of that exponential 16. So 16 v power equals 67. Okay. Again, log base 16 of 16 is going to cancel or simplify down to 1, and then you end up with just a v, and you get log base 16 of 67. Again, we don't have log base 16 on our calculator, so we're going to go ahead and use a log 67 divided by log 16. And I use log base 10, which is this one right here. Okay, but you could very well have used ln, which is log base e, which is this one. So either one's correct, is doable. You just have to use and be consistent with 1. Alright, so log base 10 of 67, that's what I typed in, divided by log base 10 of 16, that gets you 1.5165, and that is approximately equal to, right? I know I wrote equal, but that's approximate. Okay, number 3, excuse me, number 5, base 3 or base 69, we're going to go and do a log base 3. So we're going to go log base 3 both sides. So log base 3 of 3a equals log base 3 of 69. Okay. Again, by doing this, we would just be left with a equals, and then that would equal log base 3 of 69. Again, my calculator can't do that, so I'm going to go ahead and use, I'm going to use ln this time around, right? So, and again, be consistent. If I use ln, just keep using ln. So ln of 69 divided by ln. So don't use log. If I decide to use ln, I gotta keep using ln. Log ln of 3. So ln 69 divided by ln 3. And you notice if I do the same thing, log of 69 divided by log 3, you notice I get the same answer. Okay? And you can try on your own. I'm not going to do it here, but if you mix log and ln or natural logs, you will definitely get opposite answers. Or not opposite, weird answers, incorrect answers. So the approximate answer, 3.854. Okay. And 4 decimal place means that you get a 0 right there, but since it's 0, we don't need to write it down. Okay, next one. This is going to be log both sides, and you have a choice of log base 6 or log base 51. I'm going to go with log base 6, which is the only way I can release that r from the exponent. So log base 6 of both sides of 6 to the r power. That's going to equal log base 6 of 51. Okay, that's going to leave me with r is approximately equal to, and you're going to figure it out using your calculator. Again, log or ln, either one is fine. So ln, I'm going to go ln 51 divided by ln of 6. That gives me 2.19. Okay, approximately 2.195. 643. Okay. If you want to round that 3 to a 4 because the 9 behind it, that's even okay. That's just even just as good. I don't know what I was trying to say. Okay, so I'm going to skip 7 and 8 because those are pretty similar. I will give you the answer though. Okay, so that one, your n is going to equal, and so that one, your answer is going to be n equals, and that one's going to end up being, and I don't know the answer off the top of my head, but I will do this for you. That's going to end up being 2.5645. Okay, number 8. Okay, same thing. Going to end up getting 1.3436. And again, you can see how I did that. Now, once you get good, I'm not saying I'm good, but once you get familiar, how about that? You get R is approximately and N is approximately equal to 1.3436. Okay. Now 9, 10, 11, 12, they're a little different, so that's why I wanted to hurry up and get to it. This is already a 12-minute video. So on this one, you're gonna have to go and tweak it a little bit first. So first off, you're gonna have to go and divide this side by 5 and this side by 5. Yes, I know it doesn't go in evenly or perfectly, but it's okay. Okay, you can use a decimal. 26 divided by 5. I'm not liking that. I'm gonna go ahead and just leave it as 26 over 5. You can leave it as 5.2 if you like. Okay. So I'm gonna go ahead and do this as. So I'm writing right here. This is gonna be 18 to the 6x power is going to equal 26 over 5. Okay, and then I'm going to go ahead and do log both sides. What log do you think I'm going to do? You can take a guess or think about it. Log base 18. That's what I'm going to do because the x is with the exponential 18. So log base 18 of 18 to the 6x power is going to equal, and that's going to be 26 over 5. Log base 18 is 26 over 5. Okay. After we apply that, we're going to get 6x on the left hand side, and then on the right hand side, we'll do a change of base. Okay, we'll do this change of base with log of, and you're going to put in the fraction unless you want to put in the decimal that you use. I believe it was 5.2 or something. Alright, so I'm going to type in 26 over 5. So log of 26 over 5, that's my argument, divided by log of 18. Just like that. We're going to get 0.5703. Okay? So this is going to end up being 0.5703. Okay? And if you have, there's definitely more numbers. You can write more. But we're not quite done. Okay? Dot, dot, dot. I'm going to go ahead and take this and divide it by 6. Right? So if you look at my calculator, I actually did not clean it out. I just left it alone, and then I'm going to take that and I'm going to go ahead and divide it. See, it says answer. I'm going to go ahead and divide it by 6. And that will give me my final answer of approximately 0.095. You can put 0 or you can put a 1, but it's a 0, so I'm just going to leave it like that. Okay? Okay, this next one. I'm going to go ahead, number 10. I'm going to go ahead and solve this first, or isolate the e. So I'm going to add 5 to both sides. Okay, so I'm right on the side, so I will end up with e to the x minus 1 power equals 10. Right, and I'm going to go ahead and start off with taking the log of both sides. Okay, guess which log I'm going to use? Log base what? That's right, log base e, because the x is stuck with the exponential of e, right? Or the exponential base e. So Now it can be log base e. If you like to put ln for short notation, that's fine. But it's going to just be log base e of x minus 1. Sorry, log base e of e to the x minus 1 equals log base e of 10. Okay. Left hand side, it's going to simplify down to x minus 1. Right hand side is going to be log base e of 10. And log base e is just an ln, like I said. You don't have to do a change of base. You just type ln of 10, and your job is done. Okay, 2.3025. Okay, I'm going to go ahead and leave that alone because I still got to finish off by adding 1. And again, just right here, the log base e of 10. If you want to do a change of base, you can do a log of 10 divided by a log of e. E is right above, or the division, so you see that it'll be exactly the same thing if I type in ln 10. Okay, so I have that answer, and then I'm just going to go ahead, and from here, I'm going to go ahead and add 1. So it'll be 3.3025, correct? So, and if you want to use a calculator, just put plus 1. So x is approximately equal to 3.3025. And yes, if you want to round the 5 to a 6, you can. Okay. Okay, the last two, same idea. Go ahead and subtract 3. Okay, so this is the last one I'm going to do for you. I know I'm not doing all of them, but I will give you the answer for the last one. So you're going to get 9 to the n plus 10 equals 81 minus 3 is 78. Okay, and we're going to go ahead and do a log both sides. What log am I going to use? Log base 9 or log base 78? That's right, I'm going to use log base 9 because I need to get rid of that 9 exponent base. Okay, left hand side is going to leave me with n plus 10 equals, and then this part right here, since I don't have a base 9 on my calculator, I'm going to have to do a change of base, so I'm going to go log base 10 of 78 divided by log base 10 of 9. And that gets me about 1.9828. Okay, and from here, okay, I'm going to go ahead and subtract 10. Okay, so on my calculator, I already have that, and I'm just going to type in minus 10. That's going to give me n is approximately equal to negative 8.0171. So watch how I do this on the calculator, especially if you kind of have an idea. So I'm going to start for number 12. I'm going to start with 54 and go ahead and add 5. Okay, and that gives me 59. Okay, I'm going to log base 11 both sides, so it's going to be log base 10 of 59 divided by log base 10 of 11. That gives me my answer, and then I need to get rid of the minus 8, which is a positive 8. So I'm going to go plus 8. And that gets me an answer of n is approximately equal to 9.7004. Okay, so that's the first 12. I know there I skipped, I believe, 3, but you do have the answers for that. Okay. Next page. Half-life of a medication is the amount of time for half of the drug to be eliminated from the body. The half-life of Advil or ibuprofen is represented by this equation. R equals m times 0.5, and then T over 2 is the power, where R is the amount of Advil remaining in the body, M is the initial dosage, and T is time in hours. So part A says, hey, you know what? You got 200 milligrams dosage Advil, and you take that at 1 p.m. Okay, how many milligrams of the medication will remain in the body at 6 p.m.? So this is just, taking this equation here and just utilizing that 200 in there for the initial dosage, and you got to figure out between 1 and 6, right, how much time has elapsed. That's all you got to do. So I'm going to go ahead and copy this down. This is going to be R, which is what we want, or the amount remaining, equals, and this is going to be 200 times 0.5, and then from 1 p.m. to 6 p.m. that's 1, 2, 3, 4, 5, 6, that's 5 hours. So that's going to be 5 divided by 2 as an exponent. Okay, and if you want, you can find out what 5 divided by 2 is, if it makes it easier for you. But for me, I'm going to go ahead and just type all of it in at once. So 200 parentheses 0.5, and then this is the part, if you don't simplify, you got to be careful. To the power of, and you want the power of parentheses because you want 5 divided by 2 to be together. Okay, and this is going to give you this is going to be approximately 35.3553 mgs for milligrams left after 5 hours. Okay. Next part. How long would it take to only have 5 milligrams in your body? Okay. So same idea again. All right. This is R equals. All right. But this time around we want 5 milligrams to be the end result. So instead of R, we're going to put 5 equals, and we're still going to take 200 milligrams, and it's going to be 0.5. This time around, it's asking how long, so we don't know. So that the time is going to be an unknown. So it's going to stay T over 2 as a power. Okay, so you're going to do some work. First, you're going to go ahead and divide it by 200. All right. And 5 over 200, you can figure out what that is, but I'm going to go ahead and just reduce it to 1 over 40. I divide each one by 5. So 1 divided 200 by 5, you get 40. And that's going to get you 0.5 to the power of T over 2. And this is why we need to learn how to solve these equations, because let's say you're a nurse and you want to find out how long until that 200 milligram of Advil is gone from the body of your patient. 5 milligram is it's just a little bit left. You might want to find out, hey, how long until it's 1 milligram left or 0.5 milligram left, and then maybe you can give them another dosage. So this is what you're trying to find out, is how long, what's the time. Okay, in this case, I'm going to go ahead and do a log of both sides. So I'm going to go ahead and do a log both sides, because now I have a base of 0.5. So that's what I'm going to do, both sides. 0.5, so log base 0.5 of 1 over 40 equals log base 0.5 of 0.5 T over 2. Okay, by doing that, this side will cancel, and that's going to leave you, I'm going to start over here, that's going to leave you a T over 2 equals, and on this side, all this right here is log base 5 of 1 over 40, which means I'm going to have to use my calculator on that. Okay, so I'm going to go log of 1 over 40 divided by log of the base, which is 0.5. That gets me 5.321. Right? So you're thinking, well, wait, if after 5 hours I still get 35, but we're not quite done, right? So let's see. Yeah. Log of 1/40th divided by log of 0.5. Okay. So that gets me 5.3219. Okay, still going down 4 decimal places. But like, see, this isn't T, this is T divided by 2. So to get rid of the 2, to get rid of the divided by 2, you have to multiply both sides by 2. So your final answer is, and then I'm going to go ahead and use a calculator, times it by 2. So it's going to take me, or it's going to take approximately 10.6438 hours. And this is the time, so it's measured in hours. Okay. Okay. New computer costs $1,500, but depreciates in value by 18% each year. Okay. Write an equation that will indicate the value of the computer at X years. Okay, so it's depreciating by 18%. So, if you want to figure out, okay, well, if you're losing 18%, then how much do you have? Well, out of 100%, if you lose 18%, okay, you still are keeping 82%. So our equation, and we can model it after the previous one. The equation would be, and let's call it, A equals. Oops, where am I at? I lost connection, so give me a second. Oh, there it is. Not sure why that looks like that. The A is like tweaking out. Okay, well, let's just forget about that. So this will be A equals. I guess the A is still there. I don't know if you can see this, but okay, so this will be A equals P for the original amount, the principal. And then since we're losing 18%, but we are still keeping 82%, so it's going to be 0.82, just like the last one was 0.5. And then it's going to be X, or to the power of X. Okay? And it's not X over 2, because this is going to be at, each year. So it's not going to be, you're not going to divide it by any number, because the number you're going to divide by is 1. So, because it's each year, meaning 1 year, so it's X divided by 1, but you can just leave it as X. Okay, so that's your equation so far. Alright, so how much will your computer be worth in 6 years? So I'm going to write this equation down as A equals, and then the original amount, 1,500, okay, times 0.82, and then 6 years, so the X, or the T value, excuse me, I don't know why I put X, would be 6. So this right here should actually be T. But it doesn't matter, you can put X if you like. Okay, I like T. Okay, and then all you gotta do is crank it out into the calculator. Okay. All right. Okay. Alright, so second part. Sorry, I had to make a second video. You just gotta type that into your calculator. So I would type in 1,500 parentheses 0.82 to the power of 6, right? And that comes out to be, you do it on your calculator, that comes out to be approximately 456.01. Excuse me. And we're not going to go 4 decimal places because this is talking about money, and we don't have any more than 1 penny, right? We don't have anything less than that. So this is about $456.01. Okay, so we can put a little dollar sign, and that would be done. Right? Okay, letter C. How long would it take before your computer is worth $0.25 or 25 cents, according to your equation? So we're going to use the same equation here, and we're going to go ahead and make it worth 25 cents, or 0.25. That's what $0.25 is. That's going to equal, it's going to start off with the principal, which is 1,500. It's going to lose, or we're going to keep 82% of it, okay, which means you lost 18% of it. And then we want to find out, you know what, how long will this take? So what's the time? Okay, again, just like how we did before, divide both sides by 1500. This is why you need to know how to solve these equations. So 0.25 divided by 1500. Right? That gives me, I don't know, but something that's probably not very nice. Okay. You make it something weird and funky, and it probably might look like this. 0.0001666, something like that. Okay. I'm going to go ahead and just leave it as 2500, 25 over I'm going to go ahead and leave this as 25 over 1500, and then I'm going to add 2 more zeros. Basically what I did was I took this decimal and I moved it back twice, so I took the decimal here and I moved it back twice, so that's how I'm getting a much larger number. Okay, oops. Okay, and if you check on the calculator, I'm going to check right now, so 25 divided by 15 and then 4 zeros, 1, 2, 3, 4, you get exactly the same thing. Okay, so with that, or you can use this decimal 0.0001666. Okay, but I like to use this because this is more precise, and this is going to equal 0.82 to the t power. Okay, I'm going to take that, I'm going to take the log of both sides. So I'm going to go ahead and do a log base both sides. Okay, and think about it, which log should you use? Log of this fraction, because this is now your base, or log of this decimal, which is now your base. So which log should you use? That's right, you should be using log 0.82. Okay, so log 0.82 of 25 over 15000. That's going to equal log base 0.82 of 0.82 to the t power. And by doing that, we will have just t on the right hand side. Left hand side though, you have to use a calculator for that. So left hand side I have, go ahead and put in your calculator, I'm going to go ahead and put in log 25 divided by 15000, close that parentheses, divided by log 0.82. Close that parentheses, and you get approximately 43.8371, and this is measured in times, and it's asking about how long would it take. So we're going to go ahead and answer it with 43.8 years. 43.8371 years. Okay. You invest 100,000 into an account with 1.1% interest compounded quarterly. Assume you don't touch the money or add money other than the interest earned. Okay, write an equation. Okay, so this equation is going to be final amount, A equals the principal, and the interest is 1.01. So remember, when we wrote this way back when we were doing exponential equations, it's 1 plus, and 1.01 is going to be 0.0101. Okay, this decimal right here, you move it two times to the left, and that's where your decimal goes. So that's going to be one decimal place is a 0, and the next one is going to be a 1. And then you can also put a 0 in front, or you don't have to. It's up to you. So it's going to be 0.0101. Okay, that's how you do your interest. And it's compounded quarterly, so that means 4 times a year, so I'm going to have to divide this by 4. So I split up my interest 4 times because it's compounded quarterly. And this is going to be for 4 times a year for, I don't know how many years, but it's going to be t. So 4 times a year for every year, so 4t. How much money we have in the account after 10 years? So after 10 years, we're going to go ahead and do the same thing again, but it's going to be A equals 100,000, 1 plus 0.0101, double check that, gotta be careful with that, divided by 4, and that'd be 4 times 10, or you can just write in 40 if you like. Makes it easier for you. Because you know 4 times 10 is 40. Okay, in your calculator, and I know you can't see it because I just reviewed the other video, but you're going to have to kind of be very careful. You may have to do a little bit at a time. You may have to do 0.0101 divided by 4, get that answer, and then add it to 1. And then do 100,000. Okay, so I'm going to go ahead and do this. So 100,000 parentheses 1 plus 0.0101 divided by 4, close parentheses. Okay, now raise all of that to the 40th power. Okay, so it's fairly straightforward actually. Okay, and that's going to give me, excuse me. So just doing all that in the calculator, you should have the answer of 1,10613.5824. But again, since we're talking about money here, this is your answer. Since we're talking about money here, we don't need anything past the pennies, so that's the 8 is the 8 pennies. 5 dimes, 8 pennies for 58 cents. So after 10 years of 1% interest, you only gain 10,000, which is actually not bad. Right? You gain, so you subtract 100,000 from here. Okay. You gain $10,000, $613.58. So after 10 years, you actually make 10 grand. Okay, 10.5 grand. Not bad. But that is 100,000, which is a lot. And that's if you don't touch it at all, which is kind of tempting to touch. Okay, how long will it take to triple your original investment? So, your original investment is 100,000. Triple will be 300,000. 1 plus 0.0101 over 4. And this is going to be 4 times how long, right? That's what they're asking, and that's what we're trying to solve for, so the t power. Okay, go ahead and do the division. Divide both sides by 100,000. And you end up with 3. Yeah, just 3. These right here cancel, and you end up with 3 equals 1 plus 0.0101 over 4 to the power of 4t. Okay. Now you may have to figure out what this is if you want to kind of figure out what the base is, because you probably don't want to leave it like that. So in my calculator, I'm going to go ahead and type in 1 plus 0.0101 divided by 4. Okay, and that gets you. Alright, so go ahead and write this as 3 equals, and if you do that, this part in the calculator, you're going to get 1.002525 to the power of 4t. Right? So now I can say, hey, you know what? I need to figure out what the t is, so I need to do the log of both sides. And I need to do the log of the base. Guess what base? Base 3 or base 1.002525? That's right. Log base 1.002525. both sides. Okay. Of 3 equals log base 1.002525 of 1.002525 to the power of 4t. Okay. Again, the reason why we're doing this, okay, is because this will simplify down to 1, and we will be left with 4t. On the left-hand side, now we're going to have to do that on the calculator. So on the left-hand side, I'm going to go ahead and put into my calculator log, which is base 10. So log base 10, or just log 3 divided by log 1.002525. Okay, and that's going to give me, so you should have this number, 435.6430. Okay, I'm going to leave on my calculator, and then because we're not quite done, okay, to solve for t, I have to take that and divide it by 4. So I'll take that and divide it by 4. So I'm leaving that number on my calculator, and I'm just going to hit divide by 4. That should take me home to t equals 108.9107. Okay, and since we're solving for t, and if you forgot, that's what the t is, and if you really forget, go back and read the question, how long would it take? Right, so how long would it take? Right, which is a measurement of time. So to triple our value to get 300,000, it would take 108.9, so almost 109 years to triple it, to go from 100,000 to 300,000. Okay guys, hopefully you enjoyed this.